Welcome back to UC Davis Live. I'm Satirius Johnson. Despite a rainy end to 2021, California is still in the grip of a mega drought. In fact, the state has experienced drought in 15 of the last 20 years. What are the prospects for the current year? What does it mean for the environment, farmers, and communities? And what steps can be taken? And what is the role of climate change in all this? Joining us to discuss these questions and more are two experts. Jay Lund is professor of civil and environmental engineering at UC Davis and director of the Center for Watershed Sciences. He's also a member of the National Academy of Engineering and an expert on California's water management systems. And Paul Ullrich is a professor in the UC Davis Department of Land, Air, and Water Resources. He studies climate change and climate data, climate modeling to understand global and regional phenomena, including heat waves and the impact of climate change on California's climate and the Sierra snowpack. Welcome to you both.
Pleasure to be here. Thank you.
Thank you.
So we are taking your questions if you're watching us live. Just leave questions in the comment section and we'll work in as many as we can. So Jay, let's start with you. What is the state of California's drought right now?
Well, we're on our third year. We had a pretty dry water year 2020, a very dry, the third driest year on record for water year 2021. The water year starts on October 1st and then runs through September 30th of the following year. Reservoir levels are lower than average right now. They've been refilling a little bit over the last couple of months, but they're still pretty low. And in parts of California, the groundwater levels will be down a bit from the previous 2 years of extra pumping.
So if current trends continue in the coming year, what are some of the impacts?
Well, I don't know what the trend is right now because we've had this alternating wet and dry months so far this wet season. But on the drier side, we could end up in a third year of a pretty serious drought with special problems for the forests, dry conditions in the forest and wildfires, and continued problems for agriculture, and they're wanting to pump additional groundwater to make up for that. And then problems for salmon and aquatic species in the rivers and estuaries. Mm-hmm.
Paul, what are some of the long-term trends we're seeing in the California climate?
Well, we're definitely seeing an increase in temperatures, and that's not particularly surprising. Obviously, in light of climate change, that is the most direct influence of increased greenhouse gas concentrations in the atmosphere. In terms of precipitation, it's a bit of a mixed bag. California, of course, has a lot of variability. It's a term we usually use in atmospheric science to refer to there just being this big spread, this big interannual spread in terms of the amount of precipitation that we would receive year to year. And so it's very difficult in order to tease out any obvious signal in the precipitation, except to note that since it is California, of course, we very often swap between dry extremes and wet extremes. Mm-hmm. So precipitation itself is staying pretty constant, I would say. But what we are seeing is a change in the phase of that precipitation. So we're seeing less snow overall and more rain.
And so how do these drought conditions in California, how do they fit into a larger regional or global trend?
So there's both climate change driven factors as well as kind of natural climate variability that invariably play into what these long-lasting conditions, particularly like this mega drought that we've been experiencing throughout the US West, that has not only impacted California, but also has led to some of the lowest levels on record for Lake Mead and the Colorado watershed. In terms of its driver, it's hard to say exactly how much of the drought is explicitly driven by climate change. Obviously, the higher temperatures are resulting, of course, in this different phasing of precipitation. And so we are seeing a very clear decline in Sierra Nevada snowpack totals, which is linked to those warmer temperatures, while precipitation, again, remains pretty consistent with what we've seen on record historically for California. There is known to be one kind of major driver here that has been around for the past several decades, and that's the Pacific Decadal Oscillation, which is a major climate mode of variability that is known to be very tightly tied to the determining whether or not basically the US West is in drought conditions or in wetter conditions. We've been in a so-called drier phase or cold phase of the Pacific Decadal Oscillation for the past several decades now, and based on our knowledge of that Pacific Decadal Oscillation, at least, we should be switching to a warm phase in the next decade, which does provide some hope of moving into perhaps a kind of wetter than average overall climate state.
So that's the projection right now but this we're talking about how many years from now that could that happen?
So generally the Pacific Decadal Oscillation operates on kind of a 30 to 50 year time frame. And so given that this cold phase has been active since about the 1990s, we're anticipating that it's anytime in the next 10 years that we might be able to see a switch in the Pacific Decadal Oscillation. Keep in mind, though, this is, of course, only one driver. Precipitation in California is ultimately not particularly predictable on kind of a year-to-year basis, but that 10% or so switch in the total amount of precipitation year to year because of these large scale modes of climate variability are very important in affecting our overall water totals. Inevitably, we're also at the mercy of things like El Nino and La Nina, which do have more localized effects on precipitation totals for the state.
Right. And so when you mean it's also a warmer and wetter, does that mean that it's also going to be like the air temperature in California could be warmer, or is it just one factor that could make the air temperature warmer?
Well, that's the one that we have the most confidence on. So we're confident that we're seeing a consistent increase in California air temperatures, and that can be explicitly fingerprinted to climate change. As a consequence, we end up also with more water vapor that tends to be in the atmosphere. This is through basic physical process whereby warmer air can just inherently hold more water vapor. And this has implications then when it comes to, for instance, extreme precipitation in the state. So we just saw over the Christmas holidays, for instance, a very severe snowstorm impact the Sierra Nevadas. One of the with some of the greatest snowfall totals basically for the past 20 years. And those type of extreme events can be also fingerprinted or associated with basically this increase in total water vapor content, which is again connected with increases in temperature of the air. And so the current projection, basically, when it comes to trying to understand precipitation in the state is generally, even though precipitation totals remain
And we are back. We just had a little technical glitch, but we are back. And we were in the middle of a conversation with Jay Lund, professor of civil and environmental engineering at UC Davis, and Paul Ullrich, who's a professor at the UC Davis Department of Land and Water Resources. We're talking about California's mega drought and climate change. Thanks for rejoining us. And let's see, Jay. Oh yeah, you're here. Okay, cool. So everyone's back. Excellent. So let's just pick up. I want to remind our viewers that we are taking your questions. If you are watching us live, just leave them in the comments section and we'll work in as many as we can. So we had kind of just left off talking about how the drought conditions in California fit into larger regional and global trends. Jay, when it comes to water use in California, how does California use its water? What's the breakdown?
Well, about 80% of human use of water in California is for agriculture, irrigated agriculture. In this part of the world, we don't get a lot of precipitation during the normal growing season, so we have to have a very extensive irrigation system. And then about 20% of human water use is for cities and urban uses, more directly for people. We also have a substantial amount of water that we allow to go out to sea and to use it, manage it a little bit for environmental purposes.
Mm-hmm. So 80%, I mean, that's going towards agriculture and other things like that, which is a big economic engine for the state. What can be done to, are there conservation measures? Are there better practices that can be used to try to lower the usage on that front, since it's such a big part of it?
Well, in the urban front, there's been a steady effort over the last 3 decades or so to reduce per capita water use, and that's been fairly successful, although we have a fair ways to go on it still. On the agricultural side, it's very difficult to conserve water in the sense that we think of as in urban areas, because basically the crops use that water to grow. And so the major way that you reduce agricultural water use is by fallowing land.
Right. So, and that's not a preferred practice, obviously.
Well, but we're going to be doing that anyway. We're going to be following about 500,000 to 1 million acres of irrigated land in California just to comply with the ending of groundwater overdraft.
I see. Okay. So what are some of the things we can do when you talk about urban conservation, I guess is that the same thing basically as domestic conservation, what people can do in their homes?
Mostly, yes.
Yes. So does that really help? I mean, people cutting back on water use at home, does that really make a difference?
It makes some difference. It's very helpful, particularly during the middle of a drought, to reduce the water use, and particularly outdoor water use is the best place to reduce water use, because if you're using water indoors and you reduce your water use, if you're in Sacramento in the Central Valley, that water that you use inside your home, it gets returned through your sewers and the wastewater treatment plants back to the system.
Right. So some of the things are like not watering your lawn, not maybe skipping filling the pool one summer. I mean, what else can people do? To save
by
water?
far the biggest one is reducing the amount of water you use on your lawns and your gardens.
Got it. Okay. Again, I just want to remind people watching right now live, if you'd like to ask a question, please just put them in the comment section and we'll work in as many as we can. Paul, should we be thinking in terms of adapting to climate change at this point?
Absolutely. Basically, we haven't even experienced the full brunt of climate change from the greenhouse gas emissions that we've done to date. Carbon dioxide has a certain kind of dormant period before you really start to experience kind of the full effects of that total amount of carbon in the atmosphere. And so as a consequence, we are confident that we have a pretty narrow window on where exactly our temperatures are going to end up by mid-century, while we can still do quite a bit in order to affect where those temperatures end up by the end of the century. But in terms of overall water availability, I mean, in the state, we basically have three primary reservoirs associated with water storage. One is snowpack, one is surface water reservoirs, and one is groundwater supply. By the end of the century, a recent study from Lawrence Berkeley National Lab projected that we will see on average a 79% decline in the total amount of average Sierra Nevada snowpack, with much of that snowpack being retained only at the highest elevations. And as a consequence, we are going to have to build adaptation infrastructure that is able to hold water from the winter season somehow, so that we can actually continue to use it in that summer season.
So what do those adaptations look like?
Well, that's, again, an area where I say that there's a lot of research going on in terms of what works really well. One thing we need to really be looking at is underground storage of water and taking advantage of the gaps that now exist basically in groundwater storage, basically pumping that water underground or flooding fields so that it naturally percolates underground, and trying to rebuild basically our groundwater reserves in the Central Valley.
Mm-hmm. Jay, any thoughts on adapting to climate change?
Oh, we're definitely going to be doing that, and we have quite a bit of flexibility. We have a lot of existing infrastructure that we can accomplish a lot by operating it a little bit differently. Some of this has implications for flood control. In the modeling simulations that we've done, the most promising things that we've seen is to try to increase the amount of flood storage that we have in the reservoirs, because we need that for the wet side of things, and to try to move some of the drought storage that we often keep in reservoirs underground. And so if we can do that over a period of years, then we can use our aquifers more for the drought storage and use our reservoirs more for the seasonal storage.
Mm-hmm. I would imagine that a lot of these things would be more easily done in areas that haven't been developed yet, but retrofitting areas that have been developed must be a challenge.
Right. It's very expensive to increase surface storage. It's just terribly expensive, and it's almost to the point where it's not worthwhile in terms of the extra water and the value of the extra water that it would produce.
Right. So what are your final thoughts for folks as we look toward the next decade or two? People living in California with these drought conditions, almost seeming a permanent state of affairs. What are your thoughts as far as how people can move forward under these conditions right now?
I'm pretty optimistic for the most part, and there's some very tough areas, particularly on the environmental side, where we're really not well prepared for this, and it's going to take a lot of soul searching and resources to figure this out. But on the human side, most urban areas, I think, are going to be able to adapt to this pretty well. They're relatively wealthy. They have a fair amount of resources to work with, and they're pretty well organized. On the agricultural side, I think we're going to see some big lumps there. As I said, we're going to have a substantial reduction in irrigated area just to eliminate groundwater overdraft, which will also coincidentally make it easier for us to get through droughts. But they're going to bear the brunt of a lot of climate change, inevitably.
And there really is there are very few other options, you know, to kind of follow, as far as, like, I mean, leaving land fallow is not, you know, it doesn't put the state in a great position economically, but there really is no choice at this point. It almost seems like it's like the nuclear option.
Well, the fortunate thing is that when you follow agricultural land, you're going to tend to follow the least valuable land on the worst soils, the least productive soils. So the impacts will not be proportionate. They'll be a bit less than that. Although if you're a farm worker and you're now unemployed, that you're going to feel that directly.
Right, right. Paul, any final thoughts as we look forward to the next, you know, decade or two?
Yeah, I mean, I would just echo exactly what Jay said. Unfortunately, it's agriculture, I think, that's going to be feeling the brunt of the pain associated with this, whether that be in terms of economic productivity, but also in terms of our farm worker community and in terms of other kind of environmental justice focused impacts. So we're going to be seeing higher temperatures in the Central Valley related to climate change. And as a consequence, there's going to be greater incidence of heat stress on our farm workers. There's going to be basically a need for infrastructure in order to support folks who are working in the fields and making sure that throughout the Central Valley, folks have access to clean drinking water.
Yeah, I mean, the drought, the climate change effects are far-reaching and wide-ranging, and there's just no avoiding it. Well, this has been really great. Thank you so much for coming on today.
You're welcome.
Thank you.
Jay Lund is professor of civil and environmental engineering at UC Davis and director of the Center for Watershed Sciences. And Paul Ullrich is a professor in the UC Davis Department of Land, Air, and Water Resources. On the next UC Davis Live, we'll be talking about relationships and attachment with two psychologists who study romance in people and in animals. It's coming up Thursday, February 10th at 11 a.m. Pacific. I'm Satirius Johnson, and this is UC Davis Live.